Today we're going to be talking about graphing inequalities in two variables. So the solution of an inequality in two variables will be all ordered pairs, which again make it true. That's how you tell if something is a solution. So pretty much we're just going to put them in for x and y, each ordered pair, and see if it makes it true. So I'm going to put a 3 and put a 1 in for x. And I'm going to put a 6 in for y. And I get 3 plus 12, which is 15, and that is not less than 12, so that's not a solution. So now I'm going to try the other one. Next one, 3 times 3 plus 2 times 0. That would be 9 plus 0, which would be 9, and 9 is less than 12. So that one is a solution. So I'm going to write it over here as the ordered pair 3, 0 as part of my solution set. I'm going to try 2, 2, so 3 times 2 plus 2 times 2. 6 plus 4 would give me 10, and 10 is less than 12, so that is a solution also. So include 2, 2, the ordered pair. Now I need to try 4 and 3. So 3 times 4 plus 2 times 3, that would give me 12 plus 6, which is not a solution. So this would be my final answer, the solution set. So I only had specific points to try in that case. Now we're going to talk about finding all of the solutions. And to do this, we're going to make a graph that will show all the solutions. So to graph an inequality in two variables, the first step is to graph the boundary line. That would be like if the equation were an equal sign. Choose a point on one side of the line or the other, and then always shade the true side. So we're going to make a graph here. And I have graph paper on the other ones, but I don't think I had one for this one. Now, if it were y equal 4, the y-intercept is 4, it would be a horizontal line, but is y equal to 4 included in this? Or sorry, if I put a 4 in there, it's 4 greater than 4? No, so it should be a dotted line across here to show that line is not part of the solution. So that's my boundary line. Step 2 says choose a point. I a lot of times choose the point 0, 0. So I'm going to choose the point 0, 0. If I put it in here, well, the only one I need to put in is 0 for y. Is 0 greater than 4? Is that a true or is that a false sentence? So 0 is not greater than 4. That is false. So 0, 0 is not the true side, which would mean the other side would be the true side, and you would shade above this line. So everything up here would be a solution. So the first thing, we need to get it in the right form to solve for the boundary line. So we would need to add 2x to each side. And we get y is less than or equal to 2x minus 4. So the y-intercept is negative 4, and this is kind of a tiny graph, so I'm not sure if we can be very accurate here. And then my slope is 2, so I'm going to rise 2, run 1. Rise 2, run 1. Should it be a solid or dotted line? Well, this tells me that that boundary line is included. And again, it should take up your whole graph, so make it go through the graph. Choose a point on either side. Again, I like to choose 0, 0. So if we put a 0, 0 in here, we're going to get 0 is less than or equal to 2 times 0 minus 4. 0 is less than, this would be 0 minus 4, negative 4. So is 0 less than negative 4? No, that's a false statement. So 0, 0 is not the true side, which means this side would be the true side. So I would shade all of this in on this side over here. So always shade the true side. And if 0, 0 would have been, I would have shaded the other side. So on this one, again, I need to get it in the correct form. And I think I left my x out, so there should be an x actually right here. So I'm going to add 4x to each side, which would leave me 2y equals 4x, not equal, sorry, greater than 4x plus 6. I need to divide by 2, leaving me y is greater than 2x plus 3. So to graph this, my y-intercept is 3, and my slope is 2, so rise 2, run 1, rise 2, run 1. This time it should be a dotted line through these points. Again, I'm choosing 0, 0 as my ordered pair I want to try, and you do need to show this step of what you get. 0 is greater than 2 times 0 plus 3. 0 is greater than 0 plus 3 is 3. Is 0 greater than 3? No, so every one of mine have been false so far. That won't always happen, so I shade. So 0, 0 is on the false side, so I would shade the true side, which would be this side over here. Okay, now we're going to do a word problem here. Rose sells radio advertising in 30-second or 60-second time slots. During every hour, there are up to 15 minutes available for commercial slots. How many commercial slots can she sell for 1 hour of broadcasting? So we need to define our variable, and we're going to have two variables this time. So let x equal the number of, doesn't really matter, I used it for 30-second slots, so 30-second slots. And then I used y for the number of 60-second commercials she could get in there. I guess that should maybe be commercials instead of slots. So what would our equation that we need to write here be? So and since this is in terms of minutes, I'm going to kind of change everything and think of it as minutes. So this would be really half of a minute. So 1/2 x would be the number of half minutes she could get in there, plus 1y, or just y. And what would it have to be equal to or less than? Well, we had 15 minutes as every hour, so it would have to be less than or equal to 15. So that's the equation we want to work with. First, I want to get it in the form y equals, so I'm going to subtract 1/2 x from each side and get y is less than or equal to negative 1/2 x plus 15. Now I do have a graph on the other page. Now let's think about this problem for a minute. Can we have negative time? No. So really all we're interested in is looking at the first quadrant of this information. So on this graph that we're going to use next, this is, and sorry the graph's a little blurry, but we're going to use this as just quadrant 1. So, and I'm going to go along the bottom by 2's. Well, I'm going to count every point, but so we would have 2, I'm going to kind of write maybe every other one, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, so on each line is a 2. Going up the side, I'm going to go by, I think I might be able to go by 1s up here, but I'm going to label every other one. 2, just so I can't, 4, 6, 8, 10, 12, 14, 16. You probably should label the axes. I don't have much room, so I'm going to label it over here. So this bottom axis is the 30-second commercial. Can't really read that, but you know what I'm saying. And this one here would be the 1-minute commercial, or 60-second commercials, represented over here. And remember, my equation was y equals negative 1/2 x plus 15. So to graph this, I'm going to use the y-intercept of 15. So on the y-axis, I have a dot at 15. I think I'm going to find the x-intercept instead of trying to use slope and graph it here. So if I want to find the x-intercept, I let y be 0, correct? So it would be 0 equals negative 1/2 x plus 15. So I'm going to subtract 15 and get negative 15 equals negative 1/2 x. So I would need to multiply both sides by negative 2 to get 30 equals x. So my y-intercept is going to be down here at 30. Or sorry, my x-intercept at 30. So I need to draw a line then that goes from here to there. So without a ruler, I won't guarantee it's straight, but it's going to be pretty close. And anything on this line would be included. And then it would be numbers out in here that are less than that, because if you put in a 0, you'll see that this would be correct down here. But we do have to consider that the commercials have to be whole numbers. You're going to have a 30-second commercial or a 1-minute commercial. So we'd have to go with whole numbers. So we could use kind of something, this specific dot here. So I guess maybe I shouldn't have shaded it all in, but it would be all the little points like 6, 2 or 10, 3 right here. So technically it's not all shaded, even though these all fit. We'd have to be a little more restraining in what we're doing.